hopefully. Well, we will. One way or the other, we're going to finish chapter 5.5 today, which is the substitution rule. And I've broken the questions into kind of three main themes. The first one we've pretty much covered, so I'm going to go through these relatively quickly. And these are integrals where the substitution that you use is pretty straightforward. So for instance, if you ever get an integral where it's a cosine of something ugly, x cubed plus 1 in this case, make x cubed plus 1 your u-sub. If you get an integral with the square root of something ugly, make the ugly thing your u-sub. If you get an integral of a basic fraction, typically the bottom is a good choice. If you have an integral where there's a bracket with a power like 50 or 100, whatever is inside the bracket is a good choice for your u-sub. And lastly, if you ever get like sine of 3x, cosine of 3x, anything where there's a trig function perhaps, or probably just a trig function to be honest, with some like 3x in it or whatever, make that your u-sub. So we've covered enough of those as a situation. There we go. So let's move on to our second theme. And these are, I should cover these up. There we go. These questions share one thing in common. They all have something to do with the trig function. Right? So there's cosines or sine cubes, there's tangents or secants, anything with a inverse trig, excuse me, or a trig function kind of fall into this category. Now, some of these are very straightforward, and because of that, you can kind of talk yourself out of them. So in this one here, what would my u-sub be? Not a lot happening here, so what would my u-sub be?
2x.
Yeah. Now, here's the first one that we're going to look at that's a little bit different. Question 4, and later on question 15 are examples of these. So I'm going to do question 4. Suppose you are being asked to do an integral that only involves sines and cosines, you know, maybe sine cubed, cosine squared, something like that. You might say, I wonder how you choose the u-sub. So your u-sub in every single one of these, so that's this question and later on 15, is only one of two things. It's either sine theta or cosine theta. Not sine cubed, not sine squared, if there was that involved, just simply sine theta or cosine theta. Which one of those do you think would be the good choice?
I think maybe sine, because the cosine wouldn't be able to get rid of all the extra sines. It wouldn't be able to get rid of all three of them if like canceling it out.
Yes, I would agree with you. So the correct answer is sine theta for the reasons you just said. So let's go through the process. You differentiate with respect to theta, which gives you a cosine. You do what I call the crossover. Essentially, you're now rewriting it in terms of differentials. That's the jargon term for that. Divide both sides by a cosine to isolate the d theta. Pretty standard, right? Once you pick the u-sub, this is pretty much what your working looks like. Then you move over here and sine cubed becomes u cubed. I'll just leave the cosine theta alone for a minute and replace the d theta by 1 over cosine du. And if you do it correctly, can you see what happens is, if you pick a good u-sub, shouldn't line 3, this is line 3, shouldn't line 3 just be an integral with u's in it? No thetas at all, just u's in it. And it should be an integral that's easy to do. That's a sign that you've done this correctly. And so, power rule. And then replace the u with sine theta. Does that make sense? Does that U sub seem reasonable when you see the way it works out? Now you might say, well, what would happen if I did cosine theta? Suppose I decided that my U sub was cosine theta. Can you trust me that when you got to this line here, there'd be some sine squared thetas left over that you can get rid of? And if you get bits that are left over that use the other variable, that's very often, not always, but that's very often an indication that you've chosen the wrong U sub. So in these trig questions, since there's only two, can't you pick one, and if it doesn't work, you know it must be the other one, right? You could kind of use that logic. Are we good? Right. Let's look at this one. It's actually not a difficult question once you choose the right U sub. What would the U sub be in this question? And don't overthink it.
4 beta.
Agreed? In fact, you could do that as a linear shortcut method if you like. But since I've set it up as a substitution, I'll do that. You differentiate, you get 4. You do the crossover. So it now looks like this. And you divide both sides by 4 to isolate the d theta. Over here, secant becomes U squared. Oh, sorry. Secant is still secant. There we are. That becomes U. And this becomes 1/4 du. Just to make it look pretty. Aren't we looking at an integral that only has u's in it? And although that might look ugly to you, isn't that a standard integral, one that was in a table that I accidentally thrown away? So you're going to have to tell me, what is the integral of secant squared?
It's tangent.
It's tangent. So you get 1/4 tangent, and then you add c. Is that question finished? Is that the final answer? The one you put in WebAssign, or should I do more?
No, you need to put back the U you took out, the 4 theta.
There we go. And now I'm going to get another one of my many mumps out. Americans call that 4 theta. Is that how you pronounce it? 4 theta? You know it's not. How Americans can mispronounce another country's letters is amazing. It's 4 theta. It's not theta. It's a masculine one. It's theta. It's theta. Theta is a feminine. It's theta. It's theta, right? So get it right. It's theta. Well, I have to go through the entire Greek alphabet and correct you.
I have a question.
You go as long as you're not disagreeing with that as theta, we're good. Right. What you
Third
got?
line, is it supposed to be sine or secant?
No, it's supposed to be secant. Thank you.
Okay, good.
I think people saying 4 theta through my brain.
I would take an audio recording of you going through the whole Greek alphabet and giving us proper pronunciations. I would take that. Put it on right next to those trig sheets from yesterday.
No, is the short answer. What do you? Alpha, beta, gamma, delta, epsilon, epsilon. Few letters I don't know. There's a sigma in there, and then you finish with omega. There's a phi and a psi. Yeah, but I don't know all of them. But you probably mispronounce half of them anyway, so whatever. Now, this guy here, the next one I'm going to do is question 23. You have a secant squared and we have a tan cubed. It's sort of similar to the ones we've just done. If you ever see a combination of secants and tans, your U sub will be secant theta or tan theta. That's it, just one guy, not secant squared or anything, right? Just like only sine and only cosine, In these questions, it's only secant or only tangent. So the problem is, which one is it?
Tangent.
Correct. Lucky guess, or did you have a reason for it?
Because the tangent is to the third power, and then it's secant squared, and secant squared is easier to find the antiderivative of
Oh,
final processes.
interesting. Okay. So I'll differentiate it. What's the derivative of tan theta? So you got to have your differentiation cap on. I know this is Calc 2, but especially in substitution, don't you end up starting by differentiating things? So what's the derivative of tan theta?
Is it secant squared?
It is. So when you do the crossover, you get that. And then when you divide both sides, you isolate the d theta. So this guy becomes secant square theta. This guy becomes tan theta, becomes u cubed. And the d theta becomes 1 over secant square theta du. And these cancel. And that third line is perfect. Isn't that exactly what you want? Power rule. Add 1 to the power, divide by the new power, and then return it back to tangent. You need to be faster at your derivatives. I know we're just hitting you with it right early on, and it's probably a little unfair. The reason why you need to be right on top of it is if you have to keep going looking up bits of paper where you wrote down what the derivative of this is and the derivative of that is, first it's going to slow down the whole process. Isn't your homework going to take a lot longer because you're forever looking for derivatives of things, or for that matter, integrals of things, right? And the second one is it just stops the flow. These questions have a nice flow to them. Well, if you have to go, okay, I've got my u sub. Now I'm going to have to figure out what the tangent is. I go in, and 2 minutes later, I write it down. By the time you've written that down, haven't you kind of broke the flow? You're now saying, well, God, what do I do now? You know, I've kind of lost the thought process. Whereas if you've got like A, B, C, D, and it goes fast, you can keep that process going and it's much smoother. So, you know, practice, remembering your standard derivatives and your standard integrals. I'm going to do something I don't typically do, but I want to show you how you can recover from a question when you're not really 100% sure what the u sub is. In other words, how to identify when you've picked the wrong one. Now, as long as you can remember that the answer is going to only be secant or tangent, let's just say for argument's sake that you decide to do a secant, right? Could happen, 50-50, you pick the wrong one. You differentiate with respect to theta, and somebody's going to make me feel really good today. What's the derivative of secant theta?
It would be secant theta tan theta.
Almost correct, but it's secant theta tan theta, okay?
Okay.
So what you now have, secant theta tan theta d theta. Nothing particularly, well, I mean, it's ugly, but there's nothing obviously wrong yet. And so you isolate the d theta. So let's see what happens. We go over here. Secant squared becomes u squared. You leave the tan cubed alone. And the d theta, the d theta becomes 1 over a secant theta, a tan theta with a du. So you try and make it pretty, and you can, oh, well, I can cancel one of them out. And so what do I get? I get a u squared tan squared theta over secant theta du. So you try fighting it a little bit more and you say, oh, wait a minute, that could be a u. And you get a u squared over a u tan squared theta du. I guess I could cancel a u. But no matter what I do you see that you kind of end up with some thetas left over? So if you ever do the wrong u sub, even if you work as hard as you can to try and fix it, you'll probably get to the point where there's something left over that you just can't really deal with. And that's a good sign that it's the wrong one. Well, if you know it's the wrong one, can't you then just go and pick the right one and it works? So it's not totally irredeemable, right? You'll be able to fix it. It's just that you spend time. Maybe doing something you don't want, but you learn from that. Because see, the next time I see one of these, won't I probably pick the u sub correctly? Because I remember when I did it wrong, how much work it cost me, and it ended up being the other one. So, you know, you do 3 or 4, you kind of get used to them and you start picking the right one from the choice. Okay. Looking at a different situation here. 26. Who is your u sub going to be in question 26? Now, if you get it wrong, I'll just tell you that's the wrong one, and then you pick the other one, right? Secant or tan? That's the only choice you get in these questions. Single.
Tangent.
Agreed. Why Mia? Lucky guess, or you got a feel for it this time?
I got a feel for it because once you find the derivative of tangent, it's secant squared theta.
Right, so won't that end? Oh, thank you for theta. A over u is what it would turn into, right? It works really well. If you do the other one, yeah. Okay, 25, just to get the last one out of the way. What would be the u sub in a question that looked like this?
Would it be inverse tan?
Well done. Have you got a feeling for? Yes, that's the right answer. What was why was your gut feeling telling you that? What made you think that was the right direction?
Well, I knew it was either going to be the denominator or the number with the e, and I chose.
Right. So at least you reduced it to a 50-50, right? And if this one didn't work, you would have tried the 1 plus x squared, I'm assuming. And that would have worked. Have you noticed that this question has 2 contradictory rules? Isn't rule number 1, the one she was mentioning a few months ago, if it's a fraction, pick the bottom. So in that rule, u equals 1 plus x squared would be the choice. But isn't there another rule that says e to the ugly guy is the u sub? So can you imagine there can be questions where there are 2 rules, but you don't know which one is going to win? Yeah, is it the, because I could make up another question where you would pick the guy in the bottom, right? Rather than the other one, right? So I guess in those questions, you may have 2 equally valid choices, and you might just have to pick the wrong one to find out who the right one is. But this is the right one. I'll just leave it at that. Can you trust me that you end up with 2 over u eventually, and off you go and get the answer? So that is the end of our second theme. So if I find my bits of paper, which I've probably thrown away somewhere, here we go. Our 3 themes today have been just the normal ones, right? The ones that have rules, nothing too special. And then we had things we trig, which is what we just finished. And this is the last theme, this one. And you're not going to like this one because all the tricks that I've talked about, you know, pick the guy in the bottom, you know, it's a sine or it's a cosine, they work 99% of the time. the tricks that I've told you about will give you the right U sub, and that U sub gets you the answer, and it's great. But these guys are special cases. And what a special case to me means is, for whatever reason, it might not be the obvious U sub, or it might be the obvious U sub, but you have to tweak it to make it work, right? So there's something special, extra, if you prefer, about it. Now let's take this one. There isn't an awful lot that you could pick as your U sub. So the U sub, and I've written it down already, I hope is pretty obvious. Isn't this the rule? If it's a fraction, the guy on the bottom is your U sub. Would you agree that's a pretty standard rule? When you get a fraction and nothing miraculous, whatever's in the bottom is your U sub. So far, so good. Now, let's go through the process and we'll see what might cause problems. Nothing too special happening there. Put a little bracket around it. There's my crossover. And then divide. To isolate the dt. Would you agree nothing remarkable has happened yet? It's been pretty standard. Right, go over here and you've got t plus 1, I'll put a little bracket around it, over u times 1 over 8t plus 8 du. And now the problem starts. We don't want any t's, right? Those t's have to go away, right? And it might superficially look like, well, I've picked the wrong U sub, that's why it looks so weird. But it's not, is it? We can fix this, can't we, with a little bit extra algebra? Can you see anything that we can do to help this, you know, go along a little bit further?
Factor out an 8.
Okay, let's do that. Can you see why that's such a good idea? And we can cancel them. I like to write these things a little bit ugly. It helps me. I'm going to write it as 1/8 that guy. That gets me 1/8 natural log of u, and then I can just return the u back into it, in this case t's. So that particular special case wasn't that the U sub was hard to find or unusual. Wasn't it just you had to be a little bit more careful about, you know, making it look pretty at the end, right? Getting rid of the t's. Now, you should always be in the lookout. If you're pretty comfortable, I got the right U sub, but the thing doesn't kind of work yet. Think of algebra. Say, is there anything I can do? Can I, you know, can I make it work? Try and make it work. This guy here, would you agree the U sub is log x? Now, apart from that, that question is pretty straightforward. So I'm not going to do anything else with that one. Question 24, on the other hand, is really ugly. Really ugly and really awkward. First, we'll work on the U sub. It's not a problem. The U sub is not where the problem's going to happen. So don't overthink it. What's the U sub?
X plus 4.
Right, isn't it the guy inside the square root rule? Remember, that's one of our many little rules. Hey, no biggie. I can do that. If you differentiate x plus 4, you get 1. If you do the crossover, you're actually finished. This is where the problem starts. And you will say, I must have picked the wrong U sub. There's an X left over, and you're not meant to have X's left over, right? They're meant to disappear. And there's nothing there that I can kill it with, right? There's not some X's in the bottom and whatever. And so you're going to look at that and say, I've chosen the wrong U sub. And 99% of the time you're right. You did choose the wrong U sub. But 1% of the time, the special cases, as this one is, you have not chosen the wrong U sub. You just have to figure a way of making that X turn into a U.
U minus 4.
Where did he get that from? I mean, he didn't just guess it. I'm sure he knew what the answer.
Substitution.
Yeah. Can you go up there and just rearrange it? If U is X plus 4, isn't X U minus 4? Agreed? So this fella now turns into that. And we got this guy. And then you're going to say, or I would probably say, well, great. You've turned an ugly square root integral into another different ugly square root integral. I got no benefit. Not true. That one, I can't do anything about. This one I can. Any ideas how I could rewrite this to allow me to go further?
You can distribute out the u to the power of 1/2 into both terms.
So u times that gets me 3/2, and -4 times that gets me -4 to the 1/2. Are you comfortable with what happened in those two lines? I know that is ugly, but isn't it also doable? Can't we integrate this? Because isn't it just power rule with fractional powers? So add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, which is the same as multiplying by 2/3. Make it look pretty. Style points. One more line and we're finished. What should I do to complete this question?
Sub the use back.
Yeah. You comfortable with that? So, I mean, if you look at it, it doesn't look that ugly. I mean, it looks like it's not got a lot going on for it. Do you see how ugly the process was? Sometimes the simplest looking questions can cause you the greatest amount of grief. Right? So this is a very rare situation where it looks like you've picked the wrong U sub, but with a bit more work, you can actually use it, and it is the right answer. You should have been able to figure this out, even if I didn't tell you about this. If you look at that original question, would you agree the only natural U subs are X and X plus 4? Would you agree that's the only two guys in town that would ever work? U equals X and U equals X plus 4. Would you agree U equals X is always useless? Right? If you make the U sub U equals X, don't you just end up with the integral of U square root of U plus 4? Right? You don't end up with anything. So since it has to be that one, doesn't that make you think, okay, it has to be the right answer. I just have to figure out what to do with that X, right? And then maybe, see what your brain comes up with. Where should we go next? The question that I just did, which is question 24. Question 35 is also going to be very similar. What will the U sub in question 35 be? What U sub should I use in question 35?
X squared plus 39.
Right. Can you, I'm not doing that question because we've got time issues, but can you trust me? It will look very similar to this one. So when you're doing your homework question, have a look at how 24 happened and try and work the same way on 39. Next fella, another special case. I don't, well, let me start. 99% of the time, wouldn't the correct U sub be 1 plus x to the power of 20? Because isn't it a fraction? And the rule is when it's a fraction, pick the guy in the bottom. 99% of the time, that will work perfectly fine. But this is a special case situation. So in special cases, anything can happen. And let me tell you right now that 1 plus x to the 20 is not the correct U sub. So now you have to go hunting for one that is the correct U sub. What might work?
1 plus x to the 10th.
Darn close, Bobby. You're a hair's whatever. By the skin of your teeth. You're that close, but you aren't perfect.
Just 1 plus x?
Went further away. You're colder. 1 plus x to 10 was really warm.
1 plus x to
Nope.
9.
Oh, it's 1 plus x to the 9th because you.
No.
Oh,
Is it x to the
You're
10th?
getting colder. I heard that x to the 10th. Why does x to the 10th work? Think about it now that you've seen it.
oh, just to cancel out the top.
Yeah.
Okay.
Sometimes your U sub can be chosen not by what's in front of you, but what you're trying to get rid of. So aren't you kind of also wanting to get rid of the x to the 9? Right? Now, in that case, you might have had 2 or 3 near misses. Each one would have failed, but you might not know it until you tried it. And then hopefully you just say, oh God, that almost made it. I'll use this one, right? That kind of trick. Now, since I'm telling you this one's going to work, I better prove it. Power rule. Crossover. Divide both sides by 10x to the 9 to isolate the dx. Pretty standard, usual, typical kinds of lines. Right, over here, x to the 9. Oh, okay. The dx is 1 over 10x to the 9 du. Everything's looking good. And now we've got this 1 plus x to the 20. I want things to become u's. So hopefully 1 plus x to the 20 can be written down using the u. Any suggestions? So here is 1 plus x to the 20. If I think of it as 1 plus x to the 10 squared, can you see where I'm going? Won't that be 1 plus?
1 plus u to squared.
Yeah. Can you see in these special cases, nothing's handed to you on a plate? Don't you have to almost think about everything? You know, how's this going to work? Is that going to work? What's this going to become? Now, they'll cancel. And I will call this 1/10, 1 over 1 plus u squared, because in my brain, that's easy to see. What is the antiderivative of 1 over 1 plus u squared?
Inverse tangent.
And then turn it back into x's. Yeah, didn't that one work out okay once you figured out the right use of? I like these. I like the special cases because to me, what makes them fun is that they're not obvious, right? You got to think about them, and sometimes you think about them and you do it wrong, but then you learn from your mistake. You know, hopefully the next time you do it a little bit better. So in this case, it was simply just x to 10. Let's look at some other special cases. Let's look at 34. And 34 is this guy. And this one qualifies under the special cases because the way I'm going to solve it is to do this. Why am I taking the original question and breaking it into two distinct pieces? There must be a reason for it. I must be doing it for some reason.
Each one individually can be turned into inverse tan more easily.
Yeah, well, this one definitely can. Won't we have to do a little u-sub on this one? What would the u-sub in this second integral be? Don't overthink it. What would the u-sub in this one be?
1 plus x squared.
Right. Can you trust me that ends up being some, I think it's 6 log u when you're finished, and then you're finished, right? So that was what made that a special case. So the last one of this, then I'll look at some homework issues I want to talk about. You know, you should always keep the best till last. And since I think most people have more issues with trig than anything else, here is our guy. I think the first problem is a big problem. Who on earth is the u-sub? And all bets are off, right? This is a special case. So you got to treat it totally fresh, like there wasn't any rules in the world. Maybe the rule works, maybe it doesn't, but treat it fresh anyway. Who's the u-sub going to be? And I don't mind you being wrong because it means you're thinking.
Would it be cosine of x?
Could be. If that top guy was sine x, I would have probably done that. But
I'm
it's
just thinking it would be like 2 sine x cosine x, and then when you
ah,
the cosine, you could cross cancel because of that. But then the bottom's still kind of gross.
yeah. Good thinking, right? So cosine x on its own doesn't work. Give me another choice. Anybody? I like questions you have to think about, puzzles. It's what makes them fun. You get nothing for me? It's okay being wrong. You can't think of anything?
Is it sine 2x?
No, but at least you're trying. That is a possibility in a different world. Nothing wrong with that as an attempt. One last shot, and then I'm going to tell you. Come on, try hard. What on earth could the u-sub be? It isn't sine 2x, and it isn't cosine x on its own.
The whole bottom, the 32, or the 45 plus cosine squared x.
Actually, isn't that being the rule that when you've got an ugly fraction, the bottom guy is your u-sub? Well, I'm going to rewrite this guy slightly differently, because you may have forgotten that isn't cos squared x really cosine x being squared. That's just a convenient way of writing it. So I'm now going to differentiate this with respect to x. Well, that's nothing. Cos x squared is the chain rule. It's 2 cosine x to the power of 1 times the derivative of cosine x, which is negative sine x. So I'm going to rewrite this a second time. It's negative 2 sine x cosine x. Does anybody remember from trig what 2 sine x cosine x is? Forget about the negative. What is 2 sine x cosine x?
Sine 2x.
And does it surprise you that it's a sine of 2x? You see this guy? So negative the sine of 2x. So when I do my crossover, du is negative the sine of 2x dx. And when I divide everybody, we get that guy. And now we're ready. It's going to be the integral of the sine of 2x over u times negative 1 over the sine of 2x du. They cancel, and you are just looking at that guy. Remarkably how nice, considering what it started off as. And that's a negative log u, which then becomes that guy. Cool question. Nice little puzzle. Right. While I'm getting set up, will you do your last name space first name for attendance? And I will show you something to do with the homework that I think you might want to know. Okay, are we good? Last name space first name? Okay, so I think I've done it. You know, I don't know, we may have already done. Oh, here we go. We haven't really done much of this, but see when you get a question that is 0 to 1, as we have here, won't you do the answer with the x equals 0 to x equals 1? So when you're finished, the answer won't be algebra, it'll be root 2, 14, 1 and 1 plus e, that kind of thing. But let's look at the u sub. What u sub would work with 39? And it's a special case. What u sub will work with question 39 that you should be looking at?
One plus e to the 2x.
If the top was e to the 2x, I would agree with you, but the top's only e to the x, so that ends up not working. But it's not a bad answer. It's a pretty sensible question answer, but it's not the right one in this case. Think special case then. In this case, the problem is the u sub that works, and it's a special one. It's not a normal one. And I can tell you, but then all you're doing is writing down what I tell you. What would work for 39?
Is it 2x?
In some situations it would be, but not this time. But it's good, you're thinking.
Is it just e to the x?
Yeah, just e to the x. Can you see why a u sub u equals e to the x is going to work? And can you trust me that that ends up being 1 over 1 plus u squared, which turns into an inverse tan? 38. What u sub will you use in question 38? Special case. What will you use? Yeah, special case. It's actually special case and it also belongs in the trig. Remember when it was trig, it has to be sine t or cosine t, right? Which one is it? Sine t or cosine t?
Would it be cosine t?
Correct. And you'll end up with a negative 1 over u squared. 37. What's the u sub? This time, nothing special, not a trick question, not a special case. U sub in 37.
1 plus 7x.
Agreed. 36, nothing special again. What's the u sub?
It would just be
3t minus
t
1.
minus 1,
Yeah.
yeah.
Agreed. Well, that's it. We're covered. And, oh, I am getting good. 11:49. Have a nice weekend, everybody. You are going to have some challenges in these substitutions. I mean, we spent a lot of time in them, but there's no way in the world I can do every possible combination in the world. So it's okay to pick the wrong u sub, as long as you realize it's the wrong one, and then you go back and pick the right one, right? You're going to learn by those mistakes. In fact, sometimes you'll learn more from the ones you got wrong than you'll learn from the ones you got right. Okay, kids? That's just life, right? You learn by your mistakes better than you learn by your successes. So it's okay to do that. So don't think that you get, because what I hope will happen is that eventually you'll do so many wrong that you'll start seeing how to do the right ones. Yeah, don't do that. It doesn't work, you know? And then you'll say, I've done that 3 times. It never worked when I did that one. I'm picking the other one. And life will speed up. Well, that's it. Bye-bye. Have a nice weekend.